We are a MySQL support consulting and development company. I have the wonderful, interesting title of Director of Server Development. I joined the company in May 2011. I talked about how we do like continuous integration and constant development process improvement on Monday. So I'm lovely bookending the conference, and this means I have to be, awake on a Friday. So next year, if I submit anything, it will be as long as it's not on Friday for like the third year in a row. So this is a wonderful job title that basically means involved in a whole bunch of development stuff and have a whole bunch of knowledge of what's going on. I started my life in the MySQL world as a developer as opposed to a user on MySQL cluster. And this was way back in 2004, which is a great, interesting bit of code. I'm a core developer of the Drizzle database. I think I was the second person to land a commit in it, which we started back in 2008. So I work for Sun and Rackspace, and I have some knowledge, is a modest way of putting it, of about the internals of MySQL-like database servers. And I will say that I am the internals person rather than ops. Like, you really don't want me to be your DBA. Like, seriously, no. But we have other people who do that, and they do their job a whole lot better. So you can leave me to tell you about how the internals are going to, hurt you. So we're talking about MySQL in the cloud as a service because that's wonderful, buzzword compliant, and there is not one magic solution. It just works, and it works absolutely perfectly. You'll get an invalid command, and nothing will go wrong when you're running that in the cloud versus on a laptop. So there's these other options, which is MySQLD, this, that, and the other. Feels like I should add those options to some of the distribution just to have it. It's a lot of small tweaks, and then you have a whole bunch of other things you need to monitor, configure, and some things just aren't going to happen, and it's a lovely pipe dream, and oh, that's nice, here's a unicorn. And hugs and unicorn. The greener grass may be on the other side. People will look at other solutions. They may think it's like, oh, well, maybe let's go run Mongo. Oh, look, you need 2 cups of reliably stored coffee. People may try other things. Some other things are really useful for what they're good for. Other things are not. It turns out for a lot of things, a generic query language is a feature, as in the old thing of, well, let's just try distributed map reduce function at Erlang. And that is obviously what you want to tell people rather than it's simple, here's a language to do it. There is a lot of legacy code out there in the wild that just relies on MySQL and a bunch of idiosyncratic features of it, is the best way to put it. And so this code still exists, and we still need to support it in some ways. So there is lots of legacy code out there from MySQL, and suddenly people may want to run this in the cloud, otherwise known as we don't want to necessarily provision our own bare metal. We may want to run it in bare metal, we may want to run it in VM, we may want to dynamically scale, or we may really want to take this old app and just be able to run it in this our new wonderful private cloud or public cloud infrastructure. Some people come around and say there's a magic drop-in replacement. If you only buy MySnake it will magically make your MySQL scale in the cloud without a single bit of application change, and it will just magically work. So these people are either ignorant, they're talking about very specific applications and specific use cases, or they're liars and charlatans. That's basically it. There is no one magic thing, and yes, I realize there are companies out there trying to sell these things, and I've just called them liars and charlatans. That's because they are. Basically, magically having things distributed and work exactly the same, if that was all possible, we'd do it for everything and it'd be a happy world, and this distributed computing thing wouldn't be hard. We'd also all have 4096 CPUs because that's easy. So what is MySQL when I talk about it? Well, there's Oracle's MySQL, which was previously Sun's MySQL, which was previously MySQL. So there's that sort of lineage, which is one thing, which is interesting to note, that Oracle as company policy does not play well with others. And will not talk, it's also company policy not to talk about not playing well with others. So there's problems with that, which consequently has you have a number of sort of forks or branches or distributions of MySQL around there. The first one that really got much traction was OWL Delta. That's sort of rolled up now into parts of MariaDB, basically because even when it wasn't Oracle, it was not necessarily Sun's policy, but at least practice, and MySQL's practice, if not policy, to really not play well with others either. So there kept on being like these patches added around there. So you basically have Oracle MySQL, you have Bacona Server, which is the company I work for, so of course you should take anything I say with a grain of salt, because obviously I have a vested interest in that succeeding. So, you know, do take that with whatever salt you want, but obviously we're awesome. Yeah, it's not a magic solution for all your problems. It may just solve more and give you slightly other ones. You know, the standard thing of it's a value proposition. There is MariaDB, which still aims to be a drop-in replacement. They have the downside of it's becoming a larger and larger delta, so how much of a drop-in replacement that it's going to be into the future is of course up to implementation details, but that's certainly their desire. But for all intents and purposes, all these are fairly similar for what I'm talking about, right? Some have some options that are going to help. There is also Drizzle out there, which is different. It's not sort of MySQL, it's sort of a database with common code heritage, the kind of the way other projects that forked a long time ago is. DML is mostly similar. DDL has some differences, but it's also mostly similar. Management is different, and I spoke about this in the cloud last year, so therefore it's not interesting, except for totally go and use it. I'm going to talk about database as a service. So typically when I talk about database as a service, it's not like here's a VM, then you install a MySQL variant and then you connect to it. Typically, when people are doing sort of database as a service, that means you don't get SSH to the host that runs the database server, you get a TCP port to connect to, and we magically do certain things to run a database for you. This is not, in fact, just for cloud providers, right? It's not for people who are just going to build their own giant public cloud and sell things on it. It can make sense for deploying apps internally. You may want to run like your own private cloud with some form of this. You may want to do some of these tricks like just as a shared hosting thing, or it may be that you sort of have sort of some idea that you want to reduce your admin overhead, or at least hit people who write bad apps on the head with a stick by preventing them if they ever run the queries in the first place. So database as a service can be thought as something you can do internal to a company to keep yourself slightly less insane, is the words I have written here. And also having an idea about how database as a service may work may help for people who are actually writing apps that are eventually going to be deployed here to know what your problem is going to be. So the real easy thing to do is run bare metal, because most of the scaling problems and application problems and everything are known problems that with some form of known solutions and a whole bunch of people with existing knowledge. So if your database as a service is an API to provisioning bare metal, this is very close to traditional hosting and tuning, and therefore we're done, just do that and you avoid all the problems. So thank you. All right, so all is good in the world, we just all run bare metal. Unfortunately, apparently that costs money, and some people don't want to do that. And so you start getting into the tricky idea of what happens when you run in sort of like, a cloud, which is basically, well, you might get bare metal, you might get a VM on something, it may just be a single VM and bare metal and all those wonderful things. So the next part of the talk, which is the what to do if you're not just going to run bare metal and solve it that way. When I was writing this, I had a flashback back to a talk I gave at OSCON, which was actually after I gave it at LCA the previous year, which was called Eat My Data, How Everybody Gets POSIX File I/O Wrong. And this got the best feedback I've ever gotten as a presenter, because OSCON lets you have funny text things there that you can view. And this was the comment I got for that talk. A bit of a whiny bitch fest, 4 stars. It's out of 5, so I'm quite happy with 4. I'll totally take 4. So I have attempted not to have too much of that ingrained in this talk, but there is a bit of that going on. So I want to talk about the idea of multi-tenancy. The idea is that you have, more than one tenant, as in more than one application on a single thing, and that thing could be, a physical machine, or it could be an individual database server. So it's one tenant per machine is easy. I mean, that's a solved problem. We probably all do that. Here is a provisioned database bare metal machine that runs one bit of application for one user, probably usually with the application logging in as root, because that's always a good idea. Or at least a user with the privilege to do absolutely anything, because SQL permissions are hard, and it's hard. that's what people may think. So we want to combine that because maybe you have 10 apps that are actually small and don't do much, and you don't want 10 machines sitting in a rack. You could just have one, because it turns out Moore's law helps you with that, and just run 10 on one. So there's this idea of shared hosting has had this for quite a long time. I mean, who remembers, like the next to nothing dollar accounts for like, PHP, MySQL web hosting, and you get like an account to a MySQL server that has access to one schema, and you just get sort of an account in a MySQL database. Well, this is actually, the naive way to do this because it's a really bad idea. So I'm going to give you a how-to. How to denial of service shared hosted MySQL, and I was chatting with Josh Berkus the other day. Don't worry, it applies to Postgres as well. So we're equal opportunity in this, and this is the best way to actually cause it. That is, the actual implications of this, especially for MySQL, are absolutely horrific. As in recovering from it is like a nightmare, nigh impossible. Start transaction with consistent snapshot is all you need to do, and then wait. So really realizing what does this mean, right? I mean, well, assuming InnoDB, because otherwise you're just crazy. So what happens, right? You start a consistent snapshot. You start a transaction with a consistent snapshot. That means you have a read view of the database at a certain point in time. So as long as other processes are there updating rows and inserting new rows, you have to keep undo information so that this transaction still gets its read view. So what happens? Well, you fill up your undo space in your InnoDB system table space. Then it grows the system table space. So InnoDB can do one file per table, but there is always a system table space which contains a couple of things. So what happens to the undo log? Well, it keeps growing because you still have more undo to write until it hits Inno space, and then everything explodes horrifically. Because you can't shrink the system table space without a whole bunch of jumping around, so good luck with that. But that's not the worst thing, of course, you can do. What if you had like shared hosting with replication in there? So you'd also have a read-only slave. Well, I'll tell you how to denial of service is that. It's really simple. Create a table, whack a whole bunch of data in it, and then just continually run alter table. Like null ops alter table, because remember, MySQL replication is single-threaded, so you're going to monopolize the entire time running queries, or otherwise just do large updates. Even better, do huge updates so it takes a whole bunch of undo log time, a whole bunch of time executing in the slave, and just basically denial of services everything else. So shared hosting is definitely not a good idea. Multi-tenancy in the one MySQL is really not a good idea. It also gives you the wonderful bits of laziness of then everyone has to write the web apps to only ever use one account to do everything because no one ever gets, two accounts on a shared hosting thing. And you also have the old admin overhead of now you get to administer a whole bunch of MySQL user accounts as well as all your other user accounts, and that doesn't really integrate with anything else. Or even with pluggable authentication in MySQL, well, that's not really useful because you have to create each specific user with what plugin they use, and it just becomes job security for systems administrators who hate themselves. Is the best way to put it. So, what about virtual machines? They're definitely cool. I mean, they're a lot cooler than they were like 20 years ago when that was like, oh my god, Hollywood's making something funny up again. But you can use these to handle a bunch of the fundamental resource constraints that are around. Because basically, the way I see it is that running MySQL sort of as a service is not so much about, hey, set this magic things, it's more about damage control, right? You want to control the amount of damage that one tenant can do to others, and the way that VMs and provisioning of things works in the cloud can do to your database service. So database servers are resource hogs, right? We'll have all the RAM, thank you. Yeah, you've got some, yeah, we'll have all of it. All of it. Yeah, disk, yeah, we'll have all of that too. Can we have more of it, thanks? More RAM, more RAM, more RAM, more disk, more disk, more disk. So we have to properly partition resources inside MySQL. There are going to be they're not going to fundamentally change some of the problems in MySQL codebase anytime before the heat death of the universe. That's what Drizzle is for. But to support legacy apps or apps that are existing there, because really, if you think about porting your app from one language or one database server to another, can be a really bad idea, because really what do you get when you just rewrite something in Java? You just get a whole bunch of different bugs along with the old ones. So it may or may not ever be a good idea. So hopefully your hypervisor helps partitioning resources. Hopefully you can at least partition static amounts of RAM per virtual machine, and that if your if you're using the services of another cloud provider, that they in fact do that and don't overcommit. Hopefully you get sort of a specific amount of provisioned disk. MySQL does not handle space at all very well, so hopefully you don't also have thinly provisioned disk that then runs out, because that would be even worse. And the big thing you have to worry about is IOPS, right? You can easily partition RAM and disk space between VMs. Actually partitioning IOPS may or may not work depending on which hypervisor you are, and it may or may not do exactly what you expect. And if you can partition all of these, this probably gets you the best isolation between multiple MySQL instances running on the same physical box. And that's ignoring the possible overhead of simply running it inside a virtual machine. So I have a joke for any Americans in the room. It's IOPS, not IHOP. Yeah. That's much less funny in the States, even though it's funnier there. So one of the problems is, of course, that we're into this stage where in our infinite wisdom some point in the past, and I use the term wisdom loosely, as you do for idiocy, a single database transaction commit is actually multiple fsyncs. I think the last count is it's at least 4. If you want crash-safe replication, maybe it's 4 or more, depending on which database server you use. If you use older versions of MySQL, you don't actually get group commits, so that's like per thing. But there's this thing called group commit, which makes it a bit nicer, because at least then you can combine these 4 fsyncs. You can do several transactions as that. So you may have 10 transactions that commit about the same time. You can group them together and set them in one set of 4 fsyncs rather than 10 sets of 4 fsyncs. It turns out the difference between like 4 and 40 fsyncs is quite significant. There is a reason that I wrote a shared library called libeatmydata. Everyone should run eatmydata that removes the wonderful bits of crash safety from their apps, or durability. So that's a great thing, and I wrote that because like testing the database server, fsyncs are really, really slow. They're really, really slow on your laptop, especially when we had spinning Rust, but they're you still have unpredictability in the cloud, so just removing fsyncs makes things run so much faster. So basically you do anything you want as long as you save fsyncs. So group commit. MariaDB has an implementation out there that's pretty cool. So this basically means you can commit things together and you get a whole bunch of performance improvements. They have their own benchmarks. I encourage you to run your own because seeing people who make the software make the benchmarks always goes, That being said, we publish a lot of our own benchmarks too, but I encourage people to run their own benchmarks correctly rather than incorrectly too. It's amazing what you can do when you set things wrongly. Percona server also has group commit. We imported the MariaDB patch, so we have a group commit patch in there. I think possibly, I'm going to just answer because I don't remember, it may actually have an Oracle implementation in 5.6. So by the time anyone packages 5.6 and anyone upgrades to it in a few years' time, perhaps you'll have group commit there too. And this will possibly also increase the number of tenants per machine, because at least then you're doing fewer fsyncs, so you can run more database servers there, because your primary resource constraint is going to actually be IOPS, no matter what. If you're going to do MySQL in the cloud or as a service, unlike drugs, MyISM, just say no, will actually work because it will only ever cause you good things, and everyone should follow that. MyISM isn't crash safe, it's not durable, replication is problematic with it, it's not high performance, that is a lie from the days of single processor machines, and it's essentially dead, right? Anyone who developed MyISM is not working at Oracle. Oracle has no interest in maintaining that. Really, the only reason MyISM is still on the server is because it's used for temporary tables and all the system tables, and refactoring the code to do system tables into something other than MyISM is kind of like taking your eyes out with a spoon. Kind of annoying. So it's going to take a while at some point. I would not be surprised if there was a mode to just disable it and it's gone in a future version. So just say no to MyISM. If someone says, but we have full text indexes, obviously you don't care about performance because that's just horrific, and there's other solutions that are better, and anyway, InnoDB is going to have that in 5.6 anyway, so your problem's solved.
Do the MariaDB folks know that MyISM is dead?
I haven't seen any patches from them to do anything with it.
Well, they're changing it to ARIA, so.
Yeah, they're changing it to ARIA, but that's been the story for 6 years, so.
The default engine for creation is InnoDB.
In 5.5 and up, yeah.
Yeah. Yeah, I hesitate to say I think ARIA will be default in MariaDB, or be functional and usable in MariaDB roughly the time Duke Nukem Forever is released. But it's like that happened now. It completely spoiled the joke, so I'm not quite sure. So I'm going to say shortly after World Peace. I think I'm safe with that one. But really, I wish I got World Peace instead of Duke Nukem Forever. Half-Life 3, maybe. I know always the next version of Windows seems to take forever, so we could make that joke too. But always just use InnoDB. This is pretty much what you should enforce. For one thing, you have crash recovery. So of course, hardware is getting way more reliable and way more cheaper to get more reliable, right? No, it's getting less reliable and cheaper at the same time. And now it's like, oh, cloud, good, we can provision a whole bunch of unreliable machines if they go down, we don't care. So you want something that has some kind of crash safety, and this is ignoring the current open bugs that mean that you don't actually have crash safety in some bits that have been there for a long time. So one thing, of course, if you're running database as a service, like doing MyISM recovery for people and running recovery and attempting to rescue their tables and waiting the 4 days to run a consistency check on large enough tables is going to be a support nightmare. I mean, really, it's because you're lost of money in running support. So set the default engine to InnoDB. In Percona Server, we have an option which is enforce storage engine, which does lovely things because it gives you an error. So MySQL has this idea of SQL modes, which is roughly the way to cause application developers headaches, is the best way to describe that. So, sorry, but there they are. If the no engine substitution SQL mode is enabled, if you have enforced storage engine set and someone explicitly asks for another storage engine, they will get an error. So you say you cannot create a table with MyISM, and if you have enforce no engine substitution disabled, you'll get a warning. So you can basically make people sort of magically use InnoDB by setting enforce storage engine to InnoDB and the default SQL mode to something with no engine substitution enabled. But if they really want to do something stupid, and you can say we won't support you in this case, they can in fact go and create a MyISM table. So that's a pretty cool little feature. I'm not aware of anyone else having picked up that patch because the MySQL server variance landscape is wonderfully fragmented without sort of a central point that would be considered upstream or common patch corolarities. So as users, I'm sure you're all happy about that. Enospace. Never, ever, 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 ever hit Enospace with MySQL. Remember the denial of service thing with that? Well, it gets worse. If you have bin logs for replication, you don't have the right server options enabled, well, you may get a transactions, like manage to get it into the InnoDB logs, but not into the bin logs. You may suddenly hit Enospace with weird temporary files. You may just like alter table explode in the middle. And so how do you prevent this? One of the things is, if you're running, this is a service, you basically never want to hit Enospace. So you basically want to make it very, very hard for someone to ever hit Enospace. So how can you do this? One of the interesting ways is to just use InnoDB with file per table. So you can have less things suddenly growing the system table space to something huge. That's a good way to do things. You can just monitor free disk space using standard tools such as DF, which I believe will work on everything but any file system that does transparent compression and snapshots and the like. But that's, don't do that. Use XFS. There is no other file system for running databases on. Use XFS. No one's contradicting me. Brilliant.
Why?
Because everything else is slow and abysmal. XFS basically gets out of the way. And doesn't have very many global contention points in the file system, so we can actually just do a whole bunch more concurrent I/O and direct I/O, and it just sort of does. It's giving you names to things in a file system, and that's about it. Fragmentation. Fragmentation will also hurt you a bit. There are some things that help with that, like the way InnoDB sort of extends files. If you make that a bit larger, it becomes less of a worse problem. There is the other problem of fragmentation inside InnoDB table spaces. Good luck with that. That's something that can't really be avoided now. So with Extra Backup, which is the open source online backup tool for InnoDB, Oracle has one that's proprietary. and everyone else uses extra backup. We thought at some point, could we do something with that? There are some tricky things to do in there, because it turns out that people always want their backups to work, so it's always priority one. And then people, when you're doing something tricky-dicky with the InnoDB data files, people still want their data back there, so it becomes a very much of, intense thing to making sure it's always going to work. So there may be something in the future, but, we're talking at least a year off before we consider sketching out on a whiteboard how to do it. And once you know how to do something, then to actually doing it is always 2 weeks, right? So we'll see that. The other thing you could do to prevent InnoSpace is do statically allocated InnoDB table spaces. So you can actually tell an InnoDB configuration, hey, just create a 1 terabyte table space and be done with it, and don't let people allocate over that. That has the other issue of that disk space will be reserved for InnoDB only and InnoDB itself. It has other issues. You can't then sort of unhook the table space and do some InnoDB tricks there. It has the disadvantage of you now get different error messages when you run out of space in your InnoDB table space. And I would not bet that those code paths are tested at all. I would not run those code paths. I'd do file per table and let it organically grow, because that's what the vast majority of people run, and that will be what has actually seen stuff in that in the wild. There are decent sized parts of MySQL Server and InnoDB that are tested by your gracious selves, the users of our software, in production, because that's where you test it. Yeah, so there is, just a scary thing, the only open source InnoDB crash test thing, the first one of that came out of Facebook, right? For crash testing of InnoDB. So that's kind of like Oracle says, here it is, it magically works. How can we verify it? Good luck with that. So those code paths especially have statically indicated data files. I wouldn't exercise them, but feel free to. I'm sure that will be great to have in a support contract that must work. So the idea is that basically the best thing seems to be run InnoDB file per table and monitor for how much disk space is left. And do the monitoring way, it's not kind of like, oh, am I nearly running out? But project at how much disk usage goes up to when you're going to fill up the disk. The InnoDB undo log, so transactions get a consistent read view. Well, of course, you can't purge the old rows, or for anyone's familiar with Postgres, letting you vacuum the old stuff up until that transaction's done. Right? So keeping old transactions running can be quite bad. There is currently no magical feature to limit how much undo log can use on disk. That would be a great feature. If anyone wants to sponsor that development of it, talk to me. We can tell you roughly how much it'll cost, and that'll be great, and everyone will love you forever. But you can't currently limit that. It's kind of like unbounds growing. And this is sort of a wonderful disconnect in the database world between academic awesomeness and the practicalities of running a database server. There's these wonderful two worlds of like this wonderful academic and then someone's like, I have to run this and support it. So there's two wonderful conflicting worlds there, which is hilarious if you're the person having to run it. So there's this other feature we have, which is called kill idle transactions, which is at least in the Facebook patch set and for Kona server. The idea is that transactions that are sitting there doing nothing for some period of time, just come in and kill them. So therefore, if you have a transaction that's left over by some app carelessly with the old read view and maybe some locks held, row locks especially, row locks are another good contention point that can get you in trouble on apps. It'll just kill them off, and then you'll be able to run purge and the like for get rid of the old rows, and undo space gets cleaned up. This doesn't help with non-idle transactions. So this kill idle transactions would help with the denial of service attack of a start transaction with consistent snapshot and just sitting there doing nothing. Kill idle transactions won't help if you do something horrific like do small updates all the time or run small queries every so often. So if someone, which is more like someone being evil or a particular form of nasty bug rather than someone just being careless and forgetting to close a connection. The other way is to write a script yourself that simply looks at the age of any connection, and if it's too old, just kill it. Sorry, you've been running too long. 5 minutes is the max amount of time you have. You're gone. That's fairly easy and could be done with, a bit of Perl, a bit of Shell. You could probably do it in a stored procedure, an SQL 2003 stored procedure in the database server if you're feeling particularly masochistic that day. But that's a pretty simple thing to do as well. World of hurt with bin logs and InnoSpace. So of course you have bin logs that rotate for doing replication, because odds are if you're doing MySQL at some point, you're either going to want the replication logs or bin logs, because it's a binary format as opposed to the text format, and somehow we've stuck with bin log as a term instead of like replication log or something sensible, because it's awfully important that you're in the know to understand what's going on. This would hurt if you enospace with bin logs. I mean, we have sort of group commit and two-phase. Some MySQL distributions do have two-phase commit going on between InnoDB and the bin log, so that you can actually do crash recovery, where you get back the state of your transactions in InnoDB and the state of transactions in the log for replication to be the same. If they're different, of course, that means you may replicate a transaction that is not actually stored on the master, or you may have a transaction on the master that's not actually replicated around crash recovery. And that would be a bad thing, so don't hit enospace on bin logs, because I can tell you now, those code paths inside the MySQL server are not tested. Like, good luck if they work. They're definitely not. They're not going to be tested at all. Because the best thing you can do if you ever want to find bugs in software, fill up the disk and attempt to use it at all. None of your software works, by the way. Like, if you've ever had a laptop done, you'll know none of it works. Even better if you run out of inodes. But it's a great way of finding bugs in software. There is a parameter called max bin log size, and you think, that's brilliant. I'll just set this MySQL server parameter. It will solve all my problems for the amount of disk space used by bin logs. So if I could just limit how much InnoDB uses and limits the bin log usage, and then I can make sure users never hit enospace. That's just the size of an individual file. So this is basically a workaround for the downfalls of ext3 and how unlinked performance is horrific and is very interrupting. So basically, that's all that's useful for. And for systems that couldn't have files more than 2 gigabytes, it's also useful for. And apart from that, it's not. And of course, we can't actually front truncate the log or rotate it, so it's in effect how big individual size can get. In Bacono Server, we have a patch for max bin log files. So then you can specify the maximum bin log size could be a gigabyte. You set max bin log files to 20, and the absolute maximum amount of disk space that the bin logs could take up would then be 20 times 10, or 2 times, so much disk space. The server rotates the bin log files, so the old ones fall off the back end when you get to max bin log files, or you have max bin log age, so you keep a week's worth, which is an existing option in the MySQL server. Of course, you can do an awful lot of transactions in a week, which is not a disk space limit, that's a time limit. The server does rotate the bin log files on other conditions, so this max bin log files times max bin log size is an upper limit rather than a constant limit. There are other files, temporary files that the MySQL server uses that's going to cause you trouble. Many types of temporary files. There are temporary files that are done during query execution. There is file sort temporary files. There is temporary files to do with alter table. There are temporary files and explicit temporary tables that you may create inside transactions. And there are temporary files as part of replication. So the most little known bit of foo is the fact that the MySQL replication logs, so the bin log there, only ever has things written to it that is committed. So so if you start a transaction, start doing updates, those updates are actually stored in a memory buffer until it gets to the server option of bin log cache size, which by default is 32K. If it gets to 30K, it then writes that to a temporary file on disk and streams it out there. And then at the end, when you commit the transaction, if you can imagine, you can actually do a fair amount of updates now, especially if you're doing row-based binary logging. So if you're doing the reliable, as in the possible to ever get correct, ignoring the code, row-based logging, you can get pretty much more than 30K by updating a single blob or inserting a single blob, right? So then you write a temporary file on disk, you then go back to the start of that, read it out, and then write it out to the bin log and unlink the temp file. So you start actually doing a lot of metadata operations in your file system at the same time, which only helps performance because that has more synchronous operations to the disk, as well as you should not ever assume that all your temporary files end up in /temp, because they don't. But also /temp is where some things go, and they're not always on disk. They can be unlinked. So the wonderful thing of an unlinked file that's still open that uses up your disk space, and you're like, ls, there's no files there. How is the file system full? That can also cause you headaches with this. So good luck with that. So there's been long answered things of perhaps we should actually just not unlink the file. So at least this sysadmin page at 4 o'clock in the morning with, oh my god, it stopped working, can have some hope of finding out that that's in fact what's going on. So users and groups and stuff is a pretty interesting problem as well. You may want to give people control of your database as a service, the ability to create users and set up their own authentication users and users in the database server. If you're like just giving people a VM with it pre-installed, I mean, you can do that pretty safely. Just give them root and be done with it. You can also probably want to give people who are giving the database as a service to, here's a MySQL instance. You may want to give them sort of the root ability on MySQL. That could be an option you could have. The only problem with that, of course, is password recovery, because it turns out no matter how much you insist people do actually store their password safely, they don't. And so recovering the root password and setting a new root password in MySQL instance, of course, involves some foo. Password recovery for root is something you may want. There is the Amazon approach. So Amazon run like relational database as a service, of which no one has ever seen what source code is there. So it's some version of MySQL with some arbitrary patches as a service. I don't see anyone who's ever seen the code for that, and it doesn't work for Amazon. So good luck with that. They enforce an API instead of using like grant and revoke, the normal SQL things. So if your application does that at all, you'd have to go and change it to use their API calls. And that's one way to do it. You then have a whole API infrastructure. If you're developing a cloud thing, then you can have your own API infrastructure to do that. And then you could have just a local daemon that does manual foo, or you have some other user for that too. At the risk of like blowing our own product's trumpet too much, we have a feature in Pacona Server that has something called a utility user. And this is the idea is that as a cloud provider, you would have like this user to connect to, not actual root. The idea is that as a cloud provider, you should not have access to everyone's data all of the time. You just sort of provision this and then sort of let them have their own data in their own space and deal with their own problems. But you can still do password recovery. So the utility user is like a bunch of command line options. That means that it's a user that cannot be dropped, it's a user that is barely seen, and it's a user that can only access specific schemas, like the MySQL schema, to then do password reset. So it has root-like qualities in some ways, but in other ways is very restricted. So it doesn't really exist, and it's not really deleted, and it's a wonderful little utility for being able to do password reset without having root access to that box, or having to log into the VM as root and then do other horrible things to it. So you could actually exist as a cloud provider, give people MySQL as a service without ever having root log into the VM or the MySQL server, and that's like pretty neat. Replication is its own set of problems. Standard awkwardness applies. There is a bunch of stuff you shouldn't do to break MySQL replication. This is a relatively known set of do's and don'ts. I say relatively known, like there's articles and piece out there. Standard awkwardness applies, so don't break it. Long-running things are still going to cause you problems. Statement-based has some problems. Row-based has other problems. None of those problems magically go away in a cloud. Backup is also useful for bootstrapping slaves and also for, backup and accidental drop table and delete all the rows and such things. MySQL dump gives you a SQL dump. It's great, bad for big data because, it holds a long-running read view for a very long time, so that's not good. Undo space grows during backup. It takes a long time to restore. Recreating indexes is not a cheap operation. And of course, unless you give it the exact correct incantation, your blobs are going to be corrupt. Extra backup is also good. Online backup for InnoDB, pretty good. You probably want to hide all the details from people. Else, unfortunately, it's not always hugely obvious to users of what to do and don't with it. So you could just have an API that automatically takes a backup and do that, or you just run it in a cron job or something. Of course, if you were going to need free space on the machine, free disk space on the machine to store the backup or to stream it to somewhere else. So that's fun. Good luck with that. It's space management again. So maybe even have a separate block device you attach to store a backup, or just stream it directly out to somewhere else. Is the other ways to do that. And of course, also spawn slaves for scale out and all that kind of things. And of course, how much control to give replication to users. And for some reason, I have a bug in my presentation. But we can wonder why that doesn't work later. Good luck is basically the whole thing. It really is good luck, and Pinpoint presentation software is great because you can actually just switch to Emacs and fix your presentation while it's running, and it jumps to the slide. So that's great. So I say good luck. There is a bunch of caveats here. So feel free to ask me questions. We have like 5 minutes or 1 minute, depending on whose clock you believe, and I'll attempt to answer in a way that doesn't make you cry in the corner. And we have a microphone-y thing.
So I'm one of those sysadmins that gets the call at 4 o'clock in the morning when the developer's done something silly and filled the disk.
Yep.
We use the Amazon Relational Database Service for our cloud SQL infrastructure. Now, you sort of touched on that they don't release the source code, and we don't really quite know how that runs. However, obviously your allegiances lie with your company, but what is your opinion on that service that is provided?
Brilliant. Because it takes a whole bunch of headaches away from people, and it's a really simple way to say, oh, I just need a database server somewhere. Well, you can just pay them and it works fairly well. So that's a bit of brilliant. There's some inflexibility you get with that, of course, as you may be aware of, like how the replication works and how to do users and stuff. So there's a bunch of limitations there. But I mean, worst case scenario, you can still SQL dump your data out and move it somewhere else. So they do have there is a way to get your stuff out fairly well, and you're somewhat under their mercy, and that will be the case for a lot of places. I mean, one thing that is a continued problem is how do you do version upgrades for if you hit a bug in MySQL that is a incorrect query result and you need to run that query and it's only fixed in the new version. Doing an upgrade is a unsolved problem in this kind of space.
Obviously Amazon lock you into a specific point version and say this is what you get, and that's it. But
and then you get to slave something awful. The service apart from great, but you don't get the source code, you have other limitations there, so that's of course something to consider. But a lot of people run it for very large sites successfully. And it's also the great thing of, then I'm not running it, someone else is, which I am all for a bunch of things. Do your core business, outsource everything else.
G'day. The max binlog days and max binlog
count, whatever it is.
Whatever they are. Do they take into account whether or not a slave requires those logs to replicate? No. So that's a good way to kill slaves?
So if you have slaves lagging behind too far, then yeah, but odds are if they're lagging behind too far, they're probably offline and you shouldn't be querying them for old data anyway. So arguably they're already broken. But if you are doing the thing where you lag slaves, so you do the intentional slave is 1 day behind, you probably want to make sure that you have at least a day's worth of logs, which is of course problematic if you're doing binlog size as opposed to binlog time.
Right, you kind of need both.
Yeah, you may.
How do they interact if you set both?
If you set both, then it does it, whichever causes it to expire makes it expire. So it's literally, you have two routines there. Check if it's older than whatever, then it will expire. I'll check if there's a number of files adds up to the size or expire. Yeah.
Cool. Just wanted to ask about, I was imagining maybe you might talk about automatic scaling or something like that, but that comes under the magic wish.
That's the liars and charlatans slide. Anything offer it to be magic is like, either telling you a fib very convincingly, because some of them are, or which is unfortunate. It's just doesn't seem to be magic. For some apps, yes, it is magic. Some things do really well for key lookups. It turns out that some people run SQL queries that aren't simple key lookups, and there it falls apart. And that's ignoring correctness. So you want the same results in reasonable time, which is harder than it looks for these magic scaling solutions.
So, as the developer of an application that I'd love to, send to the cloud, because that seems to be where all the money is. What advice would you give on things not to really avoid early, but rather than have really fall over later? What things should I be thinking about early on in terms of how we, design Samba and I want to put Samba AD in the cloud?
Yeah.
Any particular things you think? Space seems like I'm looking for a world of pain in there, but any other sort of things?
If you're writing another app that you're looking to put in there, we see space is always a problem. Competition for disk is always an issue. So if you actually ever have to wait for a disk to sync, that latency can spike. And it's not so much, we get pretty good stuff. It's the spikes that can really hurt. So we refer to this as jitter and transaction throughput, because of course, transactions wait for commit, and There's actually a variety of different blog posts that Vadima's done on like our MySQL performance blog of like, well, certain thing in cloud or certain product that does something, or certain versions of InnoDB of like how much jitter you have. So if you have application response times, it's usually a web page loading for a user, or in the case of Samba, maybe someone logging in. It's like, the more number of times out of 10 that it's within the margin, the better. And so it's not so much always guarantee. It's kind of like, well, if you have 9 times out of 10 is good, but 99 times out of 100 is better, and stuff like that. And you try and reduce the outliers. So it's more stuff, I'd say, of try not to ever rely on disk syncs happening. Always have an easy way to do online backup and cloning out to something else in recovery. Which, with the clustering Samba stuff is easier. But also, space is kind of thing that's pretty thin. That can be a sort of limiting thing of disk space in there for people, mainly because then they just think it's the magic cloud and don't look at it. And the same thing for memory. It's kind of like these interesting corner cases around there, but usually it comes down to also simpler administration of like, if it can be more hands-off, the better. As well as like having things like maybe utility user for people who are maybe offering this as a service to like still, hey, that's all yours, but we can reset password if you call us. We're thinking the same thing of like encrypted backups and the like, how you would possibly do that to be able to have here store your backup encrypted in the cloud, but we can recover it. If go to our vault and recover a secondary key with, or stuff like that, is other thoughts for future.
Unfortunately, this is all the time we have. I'm sure Stuart will be around in the halls.
Yeah. If you have any more questions, just come outside and I'll stand around in a shirt that looks like an organizer.
Thank you very much, Stuart.
Thank you.
We're here for the next talk.
Cool. I'll get out of the way and this time not forget my power adapter like I did on Monday. Cool.
Do you have the Thunderbolt? I don't have one. Then we're in trouble.
Does anybody have the Thunderbolt to VGA adapter?
There's one the Richard does.
Did it go missing?
Oh, there's a bunch of stuff underneath the signs there.
Yeah, everything is gone. Yes, I'm sorry. We have one. Thank you.
Excellent.
I'm sorry.
Someone did some microphone.
The other, give you the all this. Yeah, you could use this. I can give you a stick mic, but I'll need that for the questions. Okay. But you can use this and...
Do you want this one and I'll take this one, or do you want that one and I take this one? You can take that one.
Is it set for 102%?
Hello. Do I just clip this on my collar here? Is it displaying?
Yeah, I don't think it was not there, so I don't know if it's possible to what it gets there. Do you want me to go into the loop? If you can.
Is it not?
Okay, yours is 5 minutes earlier than ours. That's why I was rushing you a little bit. So could you...
I think the was online. This is what
our laptops are 5 minutes faster. So could you be on track with our laptops? That's what the time for starting.
speaking with each other on whatever is there. Right?
I've got 11:30 right now.
Yeah, it's 11:30 now.
That's what I've got.
Black clocks are out of sync.
So you guys have 11:35?
Yes.
So that's where it's still 11:30. Yeah, it's 11:30 now.
So obviously it's the laptops then. Alright.
Did something.
Yeah, what should I be? 102.768. But I don't think it's being detected.
It's not.
Well, I guess
It doesn't detect that it's in.
it's not detecting. It's not detecting.
Although when you plugged it in, it went blank for a second. Yeah, so you did that. So you knew something was happening.
Yes. No device is detected.
I can utilize the techniques
Let's start with the framework.
Now we have this going on.
We're missing a lapel mic from number 4. You haven't seen it? No, you haven't gone extra.
We only have one here, but we've got maybe. Also, I don't know. Am I dialed in? Can people hear me right now? I don't know.
What do you hear? I'm having a screen problem.
Hello.
Okay, so. Right.
Test with this.
Oh, crap.
Here, we got a different adapter. Let's try that. Actual Apple branded one.
Should just go to.
Yeah. It's not even
Someone's probably mine.
Yeah.
No, not even worse. I think that's a problem.
So click on the other one's the one you care about.
Oh, wait a minute. It's going to go up to that. There. So,
Well, I think it's up there right now.
no. It works on. Okay, good.
Well, like right now it's up there.
Yeah.
Oh, so it should
Do you have it?
Just click that.
Yes. Just trying. What resolution is that? Can you tell me? It needs to be taken.